Right, so in the second demo, what I'd like to do is to take information from this ADXL335 accelerometer and display that information somehow on the screen. So what I'd like to do is to have a dot in the display moving around the display to represent the extent by which I am moving this accelerometer around its resting position. So I'll start by connecting it first. Now this accelerometer is a 3.3 volt device, so I'll connect it to the Arduino 3.3 volt pin. I'll patch the two grounds together. So the ground for the accelerometer and the ground for the display. And I only need the X and Y axis. So I'll take the X axis, and that will go to, just looking at my sketch, I'm going to connect it to analog pin 0. And then the Y axis will go to analog pin 1. I don't need to connect the Z axis pin anywhere since this is a two-dimensional display, so I'm going to leave that alone for now. Alright, let's plug it in. I'm going to upload the sketch to make sure it works, and then we'll have a look at the sketch. I made a mistake with my ground, of course. Alright, so I had a bug in my wiring, so I misconnected the ground pin. Right, so let's try again now, see if that makes it any better. Alright. Sorry about that. Okay, so let's see what we have. We've got at rest position, we've got X around 141, 142. At rest, we've got X at X-axis reading at 341, and then the Y-axis at 341 or 340. Then if I tilt the breadboard all the way to the right, I've got 412. So that's for X, and then on the other side it is 275, say. So the reason why we're not getting anything is that I haven't calibrated my map function, which I'll explain what that is in a second. So actually I'll do that now. So what's happening here is that we've got the analog pins from the Arduino are configured as inputs. So the range of values that those can generate is from 0 to 1023. However, I only have 7 positions for X and Y axis, so I need to somehow translate the range of values that I get out of the accelerometer to possible range of values that I can display on this matrix display. So that's what the map function does. So in this case here, the map function comes with the Arduino, takes an X value, which is between these ranges, and it translates it into an integer within that range. So beforehand, I don't really know what the accelerometer is producing, so I use my serial monitor to just write down the possible extremes of values that the accelerometer gives me. So for the X-axis, it can go from 412 to the other side would be 745, say. So this is 412, and then this is 2, how much was it? I've got to check it again. 275, right? So 275. And because I've done this before, I can tell you that it'd be about the same range as for the Y, will be the same range for the X. So let's try again and upload the sketch with the new extremes. And here's a dot now. And so I'm moving the accelerometer around. Get these wires out of the way. You can see that I'm having the dot, the LED, moving accordingly. So if I go the way to the one extreme, you can see that the LED is at the bottom of the display. Other extreme goes to the other end of the display, and same thing happens with the X axis. So that's a little gimmick just to get you thinking about what can you do with displays like that when you interface them with sensors like this accelerometer. Other than that, the sketch here is pretty easy. Just set the intensity. I get my analog readings from X and Y. I use the mapping functions to get appropriate values that fit within the ranges of the matrix display, and then clear the screen and draw a single pixel before I write the contents of the buffer to the display. Do that and stay there for 50 milliseconds.